G'day and welcome to another one of my videos. Today we're going to have a look at finding the perimeter of some figures where there's some right angle triangle parts in there. And so we're going to use Pythagoras Theorem to help us find any of the missing sides. So first of all, let's look at my definition of perimeter. Remember from my previous videos, I don't like the definition of it's the distance around the outside. I prefer it's the total length of the boundaries. So starting at one vertex, move my way around the boundaries or along the boundaries and add them up as we go. And that way, if there's a missing side, we can pick that up as we're moving around. And that way we have to find that before we can then find the total of the boundaries. So remember, what if some of the sides are missing? Well, we want to find those missing sides first. And if there's a right angle triangle involved, and we already know two of the sides, then Pythagoras' theorem can help us find the third side. Now remember, there's two ways. If we're finding the hypotenuse, the longest side, then we'll add them, and if we're finding a shorter side, then we subtract them. So what is Pythagoras' theorem? Well, in any right angle triangle, the square of the hypotenuse is equal to the square of the other two sides added together. Okay, so majority of people will now know c squared equals a squared plus b squared is Pythagoras' theorem. So let's have a look at some examples. We'll start off with just some triangular examples. Now just remember that in here that we can actually move our triangle around if you've got a book or a worksheet and so on, so that it looks more familiar, but you know, sometimes they're not always like that. So there's our diagram to start off with, and we can, as I said, we can turn that around to suit us to make it easier. So let's find any of the missing sides first. You'll notice here that the hypotenuse we don't know, but we do know the two shorter sides. So it's a right angle triangle, so I can use Pythagoras' theorem, c squared equals a squared plus b squared, and I do like to tell my students that write the rule down first. Then substitute in what we know. Well, we know that the two short sides are 5 and 12, so we put those in and we've got to square them. So use our calculator, 5 squared plus 12 squared is 169. Now remember, we're trying to find this length here, which is just a side. At the moment, it's the side squared. So the opposite of squaring is finding the square root of that. And the square root of 169 is 13. So what we can now do with that 13 is place it on our diagram. So we now have all of our sides there. So once we have all of our sides, we can then find the perimeter by starting at one of the vertices. So in this case, starting here, moving along 12 centimeters plus 5 centimeters plus 13 centimeters. And then once we've done all of that, haven't missed any of the sides, and we find that our perimeter is 30 centimeters. So we just have to be careful that we don't stop here by finding that missing side and saying, yep, we've now found that that's 13, because the question did say find the perimeter. So just make sure that when you think you've finished, reread the question, perimeter, so that means we've got to total all the boundaries. So let's look at another example. So again, we've got a right angle triangle in here, and we need to find a missing side. So let's do that first. What we'll notice that it's a right angle triangle and we've got two sides, so we can use Pythagoras' theorem. So again, write down that rule. And then we substitute in what we know. Well, in this case, we know the hypotenuse. We know that value of c, so we're going to substitute that in for the c. And I can substitute in my 3.6 for either the a or the b. It doesn't matter which one I put it in place for. So what we now tend to do is I tell my students that we're finding a shorter side, so it's a takeaway question. So to find a squared, it's 5.2 squared minus the 3.6 squared. And again, our calculators are really good at doing these. So we can press that in our calculator and find that a squared is 14.08. And what we now need to do is we want to find the length of that side. It is not a squared, it's just the value of a. So the opposite of squaring is finding the square root. And when we do that, we get this really long decimal here. So we've found that this length of this side here is 3.75, etc. Now, it does say up here we want to round it off the correct 2 decimal places. Now, normally I would do or leave my rounding off to the end, but what I can see here is that they're only 1 decimal place. So if I do 2 decimal places and round it off, it's not going to affect my answer later on. So I round that off to 2 decimal places, and the value of this length here is approximately 3.75. So let's substitute that in. And now that I've got all the boundaries, I'm going to start at one of the corners and work my way around. So start here, 5.2, 3.6 and 3.75, and we add all those together, and there is the perimeter of this particular triangle. So approximately 12.55 meters. So we'll do another example, a third example. So let's find the perimeter of this figure below. So this looks a little bit more complicated. So what we will do and are allowed to assume is that these are right angles in here. But what we probably want to do is recognize that we can divide this up into what actually ends up being a square and a triangle. So we do want to find the missing sides, and to do that we're going to have to break that up, as I said. And we can see that that top part is a triangle. So how do we find the dimensions of the triangle? Well, we know that across here is 8 meters because it's the same as the bottom. We can put that in. And then we also need to calculate this bit here. So this whole part is 14 and this part here is 8. So this part here must be 6 because 8 plus 6 gives us that 14. Or 14 minus that 8 gives us that 6. So put those particular parts in, and there's our working as I pointed out. Now I've put those on the inside so I don't get them mixed up with part of the perimeter. Okay, because if I wrote the 6 out here, then I might, as I accidentally work along, go 14 plus 6. So I just find that that's a little bit useful, putting it on the inside, so that I don't get it mixed up later on. So we've got a right angle triangle in here. Remember, we've made that assumption down the bottom that it's okay to do so. So right angle triangle. And we're going to make sure that we're using this 6 and this 8 so that we can find that missing side. So right angle triangle, Pythagoras Theorem. So let's write down the rule. Substituting our 6 and 8, remembering we're finding the hypotenuse, so it's a plus question. And I've just moved through a little bit quicker here, and we find that that missing side will be 10 meters. So we can place that in. So now that we've got that in, we can then find our perimeter by working our way around, starting up here, and we've got our 10 plus our 8 plus our 8 plus our 14. Remember, this 6 and 8 is not part of it, so just be careful. Alright, and we add those up. The total of the boundaries gives us 40 meters. So, what you now need to do to get better is to practice, and then practice some more, and then practice again. And the more that you do that, you'll find it so much easier. Because if you only do it once or twice, you'll tend to forget things and miss out on finding the correct perimeter because you've missed a side or forgotten how to find a missing side. So anyway, I hope you found it useful, and good luck with all the work that you do from now. Thank you.